All right. Hello, everyone. My name is Fotios Petropoulos, and I am Associate Professor at the University of Bath. It is my absolute pleasure to have here today Nicolas Vandeput as our guest speaker for this session. And this session is part of the Master's Program Operations, Logistics, and Supply Chain Management at the University of Bath. This session is recorded, and also note that we also have people attending outside of the University of Bath, and it is indeed great to see that so many people are interested in supply chain forecasting and demand planning. Now, about our speaker, Nicolas is an expert in inventory optimization and supply chain forecasting. He has previously worked for PwC, Goodman, Bridgewater, Bridgestone, and more recently, he has founded his own consultancy company, which is called Subchange. He is also the author of 2 books that you can find on Amazon: Data Science for Supply Chain Forecasting and Inventory Optimization Models and Simulation. Today, Nicolas will be talking about best practices in demand planning for demand planning. And Nicolas, thank you so much for agreeing to deliver this talk, and the floor is yours.
Thank you, Fotios. It's a pleasure to be here with you and all the students today. Let me start. So just to introduce the class before the first slide. So the objective today is to show you and discuss with you a few of the best practices in demand planning and forecasting applied to supply chain. Let me just a short video. Let's start. So I just want to show you here and raise awareness of what happens when forecasting goes wrong, so that after in the class you understand how important is it to, well, pay attention to our prediction. So I hope I got your attention with all of those totally wrong prediction. So let's just now talk specifically about demand forecasting in supply chain. I used to do this class at university and physically ask the question to the students, pointing at them, okay, let's assume you have a supply chain and you're the manager of this supply chain. The first question that's very important, I think, is why do you need to forecast demand? So I would like, as I just cannot ask you directly the question, for you to type on the chat why you would need to forecast demand as a supply chain manager. What's the use of doing that? So please take the time to think about it and just type your answer, so we can try to interact a bit. Yeah, so I see a lot of people saying that they want to match supply, to plan for production, plan for raw material capacity. So before reducing the cost, investment decision. Those are all great answers. Leverage inventory demand, that's really perfect. I think we would all agree, and this is very important. I think that this is actually the main message of this class, is that actually you want to forecast demand because you want to act, right? I will not be talking about a theoretical exercise where we just want to forecast because we want to forecast. No, not at all. First, you need to take decision: how much to produce, where to send inventory, should you open a new plant, should you close down a factory, right? You ask yourself a question about decision you need to take, and in order to take the right decision, you need to forecast demand, okay? Forecasting demand is a mean to an end, okay? So we want to predict the future to act now, okay? Before we go further, I would just like to define a few terms. So let's just take a very simple example of a couple selling ice creams to kids, right? We have here supply, which means that they have a certain supply, a certain amount of ice cream, and they get demand, right? Kids lining up to buy ice cream. At some point, if demand match supply, you get sales, right? So what we see is that the sales is, well, basically how much you sold to those kids, how much ice cream you sold, but you might also have what we would call lost sales, meaning that some kids wanted to have chocolate ice cream, but at some point you were out of stock of chocolate ice cream, so you lost the opportunity to do some sales. Overall, the demand is all the kids lining up, all the kids that wanted to have ice cream and all the original taste they wanted to have, right? And what you're trying to forecast, it's not the sales, but it's the demand. Just think about it for a second. If I wanted to forecast the sales, I could get a perfect forecast just by cutting down all of the supply. I just bring no ice cream at all, then sales is zero, and then I get a perfect forecast. You don't want to do that. You want to forecast the real demand of how many kids are going to line up and what kind of ice creams they're going to ask, okay? Now, this demand forecast is not to be confused with some other concept in the supply chain. For example, the plan. You can make a plan saying, okay, I think I'm going to get 100 kids that will want to have chocolate ice cream, but my supply is out of stock. I am out of stock, so I'm going to try to sell them another taste, right? And that's the plan, but it's something else than the forecast, right? You understand, at first you get the forecast, I'm going to get 100 kids lining up to buy chocolate ice cream, and then you come up with a plan because you like supply. Next to this, you get also the budget, which is quite important in some supply chain. You have a yearly budget exercise where people are going to try to plan for the financial year ahead, saying, okay, this is the total amount of sales we're going to do in a specific year. Again, this is not the same as forecasting demand. Finally, and I really want you to pay attention to this difference, you get also the objective or the sales objective. Maybe you're going to say to your sales team, I want you to sell 150 chocolate ice cream, and then you might get a bonus. But that's not the same as saying, next month, we expect that the demand for chocolate ice cream might be 100, right? There is the objective. You try to push people to do more. And at the same time, there is the, I would say, unbiased expectation of how much demand you're going to get. I hope this is clear for you. If you have some kind of question, feel free to type it now. I'll just take a look at the chat for a minute to see if anything isn't clear. Seems good. In any case, Fotios will take a look at the chat. If there is some question, we'll come back to it later. So now that we agree on what is a forecast, and more importantly, we agree on why we do and why do we want to do a forecast, because we want to act, we can move on to, okay, what kind of forecast should we do? So again, I'm going to say it again, the main part of this class, the main takeaway of this class is that you forecast because you want to take action. So now the question is like, okay, I understand I need to take some action. How do I set up my demand forecasting process? Well, I came up with a 4-dimension framework that says that basically you need to fix 4 things: the granularity of your forecast, the temporality of your forecast, the forecasting process, and the metrics. Okay, we're going to go through these 4 steps one by one to discuss how you need to set them up based on the action you want to do. Before we discuss this framework in detail, and especially because I know that we have on this training session, we have some students and some practitioners. I guess that for the practitioner, this will be very clear because they work already in the field. For the students, it might be a bit more theoretical. So I want you to just think about 3 different positions in supply chain: a logistic manager, a plant manager, and a marketing strategist. Okay, those guys need to take action, but they need to take different action. Logistic manager, for example, need to deploy product to shops. The plant managers needs to plan for production, whereas the marketing strategist is more thinking on the long term, like, should I launch a new product, yes or no? Okay, so when we're going to discuss the framework and the different question, always try to put yourself in the shoes of those different people, asking themselves different questions and trying to take different action, right? Again, you realize that I'm talking here about action. Those guys don't take a forecast just for the pleasure of seeing numbers. No, they need to take real decision. So the forecast is just a tool for them. Okay. Let's go on with the framework. So the first question in my framework is, okay, what is the forecast granularity you need? First, geographically, do you need to do a forecast per country, per warehouse, per total market, per region like Europe, per sales channel? Maybe you have an e-commerce and you have some brick and mortar shop, or do you just need to do a global forecast, right? Then per product, do you need to make a forecast of product by product, SKU by SKU, per segment, per brand, or even in some supply chain, you just need to forecast the total weight of your product or just a cash forecast? Again, in order to answer those questions, you need to know what kind of action you want to do. If you are the plant manager, maybe doing a global forecast is good enough because you have one plant for the whole world. On the other hand, if you're the logistic manager, you need to deploy inventory to each and every shop. So you need to do a forecast per shop. Okay. If you have any question, feel free to ask in the chat. Again, Photios will check, and I will stop at the end of this slide just to discuss with you if you have any question. Moving on, we have the temporality as well. First, we need to discuss the temporal aggregation. Do you need to do a forecast per day? It might be helpful. If you need to push stock to shops, you need to do a forecast of every single day so that every day you know what stock to replenish to those shops. You can also do a forecast per week or a forecast per month or even per quarter. If you're a plant manager and you have a monthly planning in your plant, you might want to work with a monthly forecast, and working with a daily forecast will be of no use. Okay. At the same time, you also need to ask yourself the question of the horizon. I'm just going to go back to the example so that it's as clear as possible. This guy, the logistic manager, needs to have a lot of detail for his forecast, but it's a very short-term forecast. He might not be so much interested to know that, well, in 3 months, you're going to sell that much. No, he needs to know today, right now, how much inventory to send to those shops. On the other end of the spectrum, you get this marketing strategist. This guy, he needs to know 12, 18 months ahead, okay, what is the market going to be like so that I know today if I need to launch a new product or not. Okay. Now a question for you. Again, feel free to type the answers in the chat. In terms of action, we see that we have some short-term action we can do in a supply chain, mid-term action and long-term action. Could you type in some example of short-term, mid-term and long-term action? Feel free to type them in the chat. I'll just review that. And Rahman, I'll just go back to your question in a second. Short-term, hire more temporary employees. Yeah, for sure. That might be a short-term question. Yeah, that's a good one. Long-term, and add another production line. Yeah, great. Short-term planning for labor. Yeah. Long-term capacity. Yeah, sure. Long-term, enter a new market. That's great. Yeah, great. Seems quite good. Let me show you what I have. Just before we discuss that in detail, I just want to raise the fact that from one industry to another, from one supply chain to another, the definition of long-term and short-term might change totally. If you work for a bakery, short-term could be in the next 3 hours. And if you work in the vaccine pharma industry, short-term could be the next 6 months, right? So the definition might change. On the short term, it's really a question like, how much should I ship? How much should I produce? Or should I ask for extra hours to be done in the factory? Midterm would be more like, how much of those seasonal products should I do? Should I hire some interim and those kind of things? Long term are, of course, question like, should I open a new plant? Should I hire new people? Now I want to go back to re-explain this idea. I guess it's quite natural for everyone to understand that as you go to the short term, the accuracy is higher. It's much easier to forecast the sales of the iPhone tomorrow than to forecast the sales of the iPhone in 18 months, right? So short term will be more accurate, okay? On the other hand, the more granularity you ask for, so you don't just want to forecast the iPhone in the world, but you want to forecast the sales of the iPhone per shop, per color, per size, per everything, the less accuracy you're going to get, right? So the more granular you want your forecast to be, the less accurate it is going to be, right? So when doing a forecast, people have to understand that the more granular information they're going to ask for, the less accuracy they're going to get. Then again, someone asking the question, and let me go back to this slide. Okay, but what granularity should I take? Then again, I come back to the point that it really depends on what kind of action you want to do. This marketing strategist guy, it doesn't need to have the forecast product per product, shop per shop, week per week for the next 18 months. Maybe you just need to have a global point of view of the sales, maybe per market, and not even per product, but per segment or per family. And that would be enough, right? So really the granularity depends on what kind of action you need to take, okay? Let's move on to then the process and metric. In terms of process, two main questions. Who should enrich the forecast, meaning what kind of stakeholder in your supply chain or even externally to your supply chain should every month or every week go to your forecast and edit it by saying, okay, I think we're going to sell a bit more of that or a bit less of this, right? The next question is, of course, okay, but when should we do that? Should we change the forecast every day, every week, every month? There is, and we're going to discuss that in detail, a trade-off to be made in between we're going to spend more time on the forecast, and at some point you will not be able to make it better, right? So if I ask you the question, how many iPhone are we going to sell tomorrow? Maybe if you spend an hour on the exercise, you're going to get more accurate. But if you spend 10 hours on the exercise, you won't be so much better at it, right? At some point, it will not be useful anymore for you to spend more time on the question, right? We also understand that if you're the marketing strategist guy that wants to do a forecast for the next 18 months, you can definitely spend 3 months thinking about it, right? You have the time because it's 18 months ahead. On the other hand, if you're the logistic manager and every single day you need to take a decision of how much goods to ship, you cannot spend 3 days to think about it because you need to take a decision every day, right? Next to this, we get the question of the metric. Unfortunately, as we only have 45 minutes together, I have no time to go in the deep into the details of metric. I actually love the subject, so I can only encourage you to read my books, the article I post online on my blog or on LinkedIn about metrics, because I think it's really an interesting conversation to have on which exact forecasting KPI you should take for your supply chain. On the other hand, something that is extremely important, and it's considered as like the best in class today, is to track the forecast added value of each step in the process. I think, yeah, we're going to come back to this forecast added value in a few slides, so we'll not talk about it right now. We're just going to leave that for later, and we'll come back to it.
Nicolas, there is a question in the chat from Bayan.
Yes.
What are your thoughts on grouped time series forecasting? And let's say you have 3 distribution centers. Do we build a model for each one of these distribution centers, or we build one model for all distribution centers?
Yeah, that's a very, very good question. So I would really go back to the first point I made. That is the question, what kind of action do you want to do? If the action you want to take is what's the right size of each of my DC, or the action you want to take is how much to ship in and out of those DC, definitely you need to have a forecast per DC. And even maybe depending on the complexity of the data, you need to create a model for each of those DC. Now, if the decision you want to make is, I have a factory that's above these 3 DC and I need to know how much to produce in this factory, then maybe you don't need to pay so much attention to the demand in each DC because you just need to take a look at it globally. Okay, so first question, what kind of action do you want to do? If it's something related to how much to ship in and out of those DC, then definitely you should do a forecast per DC. Yeah. Is this clear?
Hey, it's Bayan. So basically, what I guess I'm asking is, we need to know, let's say, for each distribution center, the forecast, and then we need to know the total network volume. So do we build a model for each distribution center, right? And then add those, let's say 3 forecasts and say this is the total network volume, or do we build one model predicting the total network volume? And let's say, you know, because I've done some research on group time series where we can, you know, use the optimal approach or bottoms up.
Yep.
Bottom up, top down. So I just was wondering what your thoughts were on that.
Okay, let me just, that's okay, I understand your question. Let me just rephrase that so that I'm really sure that everyone understands the question. So the question you're asking is, okay, I have 3 DC and I need at the same time to have a forecast that's correct at the global level and a forecast that needs to be correct at the DC level. So I need to have 2 levels of granularity that needs to be as good as possible. And the question is, should I do a forecast at global level and then divide it in 3 or do some kind of, let's say, weighted smart division? Or should I do it per DC and then group it at global level? The data scientist in me, the supply chain data scientist in me will tell you that you need to try to know which model is going to work best. It's nearly impossible to tell you without looking at the data and at the model, which is going to be the best. So I would advise you, you should try one way, you try the other way, and you check which one's the best, and then you move on with this one. Okay, I am sorry that for those kind of questions, there is no black or white answer. I like to say that if it was super simple, black or white answer, we wouldn't have all this class and it wouldn't be fun. So it's more of a, you should try and let's see what's the best. Okay.
Sure, yeah, thank you so much.
I'll move on and we will go back to this forecast added value. So now I have another debate for everyone.
I'm sorry, Nicolas, there's another question in the chat box. I'm sorry to interrupt you. Jorge is asking, how do we deal with product portfolios with many similar substitutes products with low switching cost from customers?
That's also quite a good question and quite a difficult one. So if you face such kind of a supply chain where you have many similar products and a customer could just go from one to the other, making a good forecast is going to get really, really difficult because it's enough that one of your product is out of stock so that all of your clients would just simply go and buy another product instead. So you will face a lot of volatility. What I would advise you, but again, it's not a black or white approach. I'm saying I would advise you to take a try and see if it works. Try to do a forecast at product family level. I'm going to go back to the slide. So you see here, instead of doing the forecast per product, maybe you should try per brand or per segment or something like that, and then try to divide it back per product. So that if one product is missing, still the forecast at the segment level will be correct. And then you can just reallocate the forecast back to the product. Yeah. And someone just noted in fashion retail, yeah, it happens a lot in fashion retail. This kind of difficulty, and I have to say this is one of the difficult aspects of forecasting, will happen in a lot of supply chain where you have short shelf life and so on. I would advise you to do the forecast per segment. Okay, so now for my small debate. So in supply chain, you have a concept in forecasting called one number forecast. I'm going to go back to those guys. The one number forecast means that you're going to align on one number, one single number for the forecast for these 3 different guys, so that the logistic manager, the plant manager, and the marketing strategist will share the exact same forecast. So you hope that they're going to be totally aligned. My question for you is, can you note down in the chat the pro and con of doing such a thing? Again, the one number forecast, the idea is that everyone in your organization, in your supply chain, is going to share the exact same forecast. Can you just type some ideas you have on, is this a good thing, a bad thing? Yeah, someone is mentioning the bullwhip effect. That would work if you align with people external to your own company. I'm talking really sharing the whole thing inside your own company, not with clients. Sorry for this confusion. I will not discuss the bullwhip effect in this class, but that's an interesting topic nevertheless. So someone's saying a good thing. Anyone think it's a bad thing? Like anyone is thinking right now, no, aligning forecast within a company, it's really bad. Someone saying it's going to get difficult to align. I have to say it's a real debate. Again, I don't want so much to come with a black or white answer. So I'll just show you some of the elements I noted down. But again, I think it's a very interesting conversation. Many people are talking about range. That's quite interesting. So let's just think about, okay, why is it a good idea? First, I mean, as a supply chain, I guess it's all a question of alignment. So if you get one single forecast, that you're sure people align on what is the agreed future, right? We have one version of the truth. Then it's also quite easy that you can aggregate and disaggregate the forecast so that everyone gets his forecast on the right aggregation level, okay? So I'm the marketing strategist guy. I'm going to get the forecast per month for the next 18 months. I'm the logistic guy. I'm going to get it per day, but still it's going to be the same total number. Okay. Now, on the other side, I have to ask some question. If you're the logistic guy, you need to have a precise forecast for the next, let's say, days, and you need to have it per SKU per shop. I'm asking you the question, how do you make a forecast per SKU per shop for the next 18 months? That looks like impossible to me. On the other hand, if you need to align all those teams, so I'm talking marketing, finance, supply, logistics, all of those guys for an 18-month forecast, and you want to do that every week or every month, it's going to be a mess. So the conclusion would be more, maybe instead of forcing yourself to align on one single number, you should try to just have the mindset so that you're sure that marketing is not going to go one direction, whereas finance people are going in another direction, right? Someone is not going to say we're going to increase market by 5%, and someone else is going to say we're going to decrease it by 10%, right? So you should try to aim for some kind of alignment on total numbers, and at the same time, I think it might be a good idea to let some people free to tweak the forecast based on the actions they want to take. Okay. Someone said you want to be aligned on assumption, not aligned number. Yeah, that's exactly my point here. Let me move on and discuss the process. So this slide is mostly for the students that are maybe not so familiar with forecasting process. So I'm just showing up here some kind of a simple and yet quite a realistic process for forecasting. So you start with a forecast baseline. So that would be a forecasting software engine, an Excel file, whatever, making a forecast. Then you get demand planners, and those guys will get some insights. Typically, they need to take care of new product launches, but also they communicate with your customer. Maybe a customer just called you and told you it's going to be a bad month, it's going to be a good month. So you can tweak the forecast, right? So those guys will update thousands of SKU, and let's imagine they just increase total volume. Then you get the sales team. And those guys, let's imagine they want to secure stock and they want to just be sure that supply will be there. So what they're going to do is they're going to increase the total volume again. Then finally, we get the SNOP meeting with the final alignment, and those guys just want to match the yearly budget. So they're just going to slightly decrease the total volumes. That's what a demand planning process will look like. Now, if you want this process to be efficient, you want to be sure that each step in the process is only going to do changes if they add value, right? You don't want the demand planner, the sales team, or the SNOP meeting to start to tweak the forecast if it just makes them worse, okay? So what we're going to do to track this is to use, I'd say, a process framework called forecast value added. It was promoted in this book, the business forecasting deal by Gilliland. From 2010. So basically you have two problems. You don't want people to spend time editing a forecast if it's just to make it worse. And at the other hand, you don't want people to spend too much time in the forecast if they cannot add so much value to it, right? Just remember this case with the iPhone. If I ask you the question, how many iPhones do you think we're gonna sell tomorrow? Maybe if you spend an hour, that's great. You added some value, you find some good forecast. But if you spend another 10 hours, you will not be able to add so much value anymore. So you should stop after an hour. So the solution for those two problems is basically to track, compared to the baseline, the added value of each step in the process. So the demand planner, we're going to track their forecast accuracy. Then we're going to track the forecast accuracy of the sales team. Then we're going to track the forecast accuracy of the SNOP team to see each and every of those teams, like, do you really add value to the baseline? Yes, no. So here on the right, I show you an example. Let me move the Zoom video here. As said, unfortunately, as we only have 45 minutes, I didn't have the time to discuss forecasting metric with you. So let's just assume for now that RMSE and MAE are just an expression of the forecast error. So high number is bad, okay? Low number is good, high is bad. Just means forecast error somehow. So let me go back to the process so that it's clear for everyone. I have a 4-step process. I have my baseline, my demand planners, my sales team, and my SNOP meeting. Now, up here, we just put some dummy benchmark, that's fine. So the forecast baseline gets here, for example, a forecast error of 72%. Then the demand planners start to act. They spend 72 hours on your forecast and they decrease the error by 4 points. Great, that's a great job. Those guys spent some time on the forecast and just made it better. It's great. Then the sales team went to edit the forecast and they couldn't reduce the error. This as a matrix, they make it worse. And you see that the bias, it means that they over forecasted by 5%. Finally, you get the SNOP team. It's just one meeting, so the time spent is much lower, but you see that they couldn't add any value. So if you start to track forecast value added each month or each cycle like this, at some point you will realize that some teams are better than others. And you can start to ask people, okay, instead of spending, for example, a sales team 20 hours on this forecast edition, you should maybe just spend 3 to 4 hours and just focus on the very few items that you're absolutely sure that you're going to add value, right? Because you don't want your team to spend 20 hours on a process where they do not add any value. Yeah, that's it for the forecast value added. If you have any question, feel free to ask so that we discuss if anything isn't clear. Especially the students, because I guess that for most of the practitioners listening, it's quite clear, whereas for the students, it might be a bit more confusing. So if you have any question, feel free to ask. Good bias in general in industry. I would say the best is 0, of course. If the bias is a bit negative, I wouldn't say it's an issue. So if you have a bias that's in between -1 to -3%, I wouldn't say it's an issue because I think it's quite natural. On the other hand, many people hope for a positive bias because they're still in the mindset of we want to secure stock. So if it's a bit too high, it's fine. Which metric is better to evaluate the accuracy? It's a very good question. Again, I absolutely love this subject. It's a complex subject, though. It would require me to show you 5 or 6 slides to decide which one's the best. So I can only encourage you to check online resources or my book or my blog to discuss that, because unfortunately I cannot have the time here to discuss. But for sure, it's not a trivial question, and it's definitely worth your time. Matt, I'm not sure I understood your question. If you can rephrase it, I will move on and then come back to it later, because I still have a few slides, so we'll be a bit out of time. So now we have this forecast value added process, and it works really great, but we need to refine it one step further. The idea now is to say that within your portfolio of product, you have some product that are worth a lot, like hammer. It's like some important product, and on the other side you have nails, which are basically worth nothing. So if I look at my forecast KPI for those items, I see that, well, hammer I was 50 off, okay, nails I was 500 off. So you would say, just looking at the numbers, okay, nails, we should really spend time on it because we were totally off by 500 units. Now the thing is that if you weight your KPI saying, okay, the hammer, it's worth, let's say, €5 per piece, whereas the nail, it's worth 1 cent per piece, you realize that if you weight the error, the hammer are much more important. So those are the guys you should pay attention to, and you shouldn't spend time with your team on the nails. I think by weighting each product in your portfolio by its value or the cost, whatever, you will be able with your team to really focus on the few products that matter the most, right? I think it's very important if you have a supply chain with very different product with different profitability. We talked about fashion industry. I'm sure that some product in fashion industry are worth much more than other. And I think that we would all agree that you want, more importantly, to be correct on the items that are worth a lot of money, and those that, well, are not costing that much like the nails, you could be wrong. It's all fine, right? And at some point, you shouldn't be comparing unit to unit, but more profit to profit or cost to cost. Okay. I will move on. So we discussed the process. Now I'm going to discuss and explain you in the next 10-15 minutes a few forecasting models so that you understand how you can set up a forecast model for your supply chain. The first type of forecasting model is what we call time series forecasting. Time series forecasting is really the simplest. It just means, okay, let's look at the past and we just assume it's going to be more or less the same in the future. If we saw a trend in the past, we're going to project this trend in the future. If we saw a seasonality in the past, we're going to project a seasonality in the future. You have a lot of time series model, a lot of academic research on the subject, and it can just really be summarized as this. We're going to look at what happened in the past and we're going to project this in the future. Somehow, time series forecasting doesn't pay attention to the fact that you're selling a specific type of product or it's a supply chain question or whatever. It's just looking at the signal, at the shape of the past demand, just trying to push it in the future. Okay. Now you have another type of forecasting model, which could be called causal forecasting, also called predictive analytics. It depends if you want to be using some marketing terms or not. And there, the idea is really to say, okay, we're going to look at what's driving demand. Is it pricing? Is it promotion? Is it, as I shown in the example, the fact that it's a holiday, whatever? I'm going to try to understand the impact of all of those drivers. So when I'm going to do a forecast for the future, I'm going to look at, okay, are we running a promotion? Are we increasing the price? Is it some holiday, stuff like that, in order to know what is going to happen in the future. So here in the example, for example, in this example, I said, okay, during the holiday, you sell less. When you do a promotion, obviously you sell more. Then you have a new competitor joining the market, so the sales decline again. Then here it's even worse. You get holidays and a new competitor. And then maybe in the future, you're going to get some positive impact, like another promotion, a price decrease. So you expect your forecast to increase. What could drive demand? Obviously, promotion, event, pricing, but you also have a lot of external things, GDP, weather, unemployment. I noted on Google search and so on. Now I want to ask you a question.
Nicolas, there is a question in the chat box.
Yes.
How do you incorporate a customer forecast? Let's say your customer is giving you a decent forecast on what they expect to order, and you have your own forecast.
Yeah.
You do an assembly forecast, consensus forecast.
Yeah, Bayan, it's an excellent question again. Let me show this on this process. So typically on this process, you might want to add your customer forecast as an extra step of its own, maybe after or before the demand planners, and you would call it customer input or something like that. Before discussing it further, I have to say it's very important and it's very good. If you have a supply chain where you're able to call your client or to get information for your client, communicate with your client, you should do it. I mean, this is the easiest. It's nearly cheating. If you can just call your client and ask, by the way, how much are you going to buy next month? And they tell you, it's awesome. I mean, forecasting is over. It's done, right? Yet, I've seen in many industries that clients are not exactly sure of how much they're going to buy because they also want to tweak the game by maybe over asking so that they're sure that you get supply. So somehow, I really advise you that customer forecast should be part of this forecast value added process. So that after planners and before sales team, you would have another row here called customer input. And you would see, is the customer input creating or removing value? And you might see over time that some clients are really good at making their own forecast and some are not that good. Okay, so you should really include it.
Matt is also asking, how do you keep the sales team engaged and own their input into the forecasting process when your forecast value added shows that they should stay out of it, yet they are the key to demand?
Yeah, Matt, that's a great question. It's also a very tricky one because it's quite challenging. So first, you should say to the sales team that the objective of the demand forecast is to give an unbiased view of the demand, and we don't want them to lose time doing a forecast. That's how we should frame it. That we don't want those guys to spend the day doing a forecast, whereas you have other team that are professional at doing it, and you have some tools that do that for them. We want those sales team to be on the field with the clients selling stuff, right? So this forecast, they should only touch it if they feel that they really have information to add and they're absolutely sure about it, but we don't want them to spend too much time. So again, for this example, if we reduce these 20 hours down to maybe 4 hours, 5 hours, maybe those numbers will get in the green. And at the same time, we divided the amount spent on it by 4. Okay. I'll move back to those 2 slides because I wanted to debate that with you, if that's fine. So I'm going to come back to this time series forecasting vs causal forecasting. So the great thing about time series forecasting, it doesn't require so much data. You have your past sales. We can just do a forecast out of it, right? On the other hand, if you like to play with scenario like, okay, what if we do a promotion? What if we reduce pricing? This will not help, right? Because time series forecasting, again, is just looking at how much you sold in the past, and let's just do a projection of that. So if you had an upward or downward trend, it will just continue, and you cannot play with scenario, okay? On the other hand, causal forecasting, it requires a lot of data. All the pricing of every single transaction you ever did, all your promotion, maybe the pricing of your competitor, and so on and so on. Some of the demand driver cannot be predicted. Let's imagine here that weather was impacting your demand, right? If it's raining, no one is buying a product. Great. Can you predict the rain for the next 6 months? No, you cannot. So it cannot really be used to forecast, right? It can be used to analyze the past and to understand demand, but it cannot be used to forecast it. Finally, I have also to say that it's not simple to do a great causal forecasting. If you think about barbecues, you need to take into account promotion, weekends, holidays, weather, because I guess it's really different if it's a good weekend in June or a good weekend in September, right? So it's definitely not easy. A last point is that you need to have, well, a lot of data, because if you want to understand the impact of an event on your sales, it's an event that needs to happen multiple times. Otherwise, it's not statistic, it's just doing a wild guess of the impact of such an event. Now, of course, the question is, and I don't see it on the slide, which one is best? So that's the debate I would like to have with you. So please take the time to type in your keyboard, which one do you prefer? Which one would you use?
In the meantime, if I may, there are a few questions in the chat box. One question is about your thoughts on methods for new product forecasting. Another is about forecasting for intermittent demands when we have just a few past data available. Another question relates to causal forecasting when it comes to hierarchies. Where do you go? Do you go top down, bottom up, etc.?
Yeah, and I'll try to, because I think in theory we still have 2 minutes and I have 2 other slides. I'll try to reply very quickly. Intermittent project with low amount of data, those are quite difficult to forecast. I have to say, I wrote a blog article about it. I would advise you just in a minute. It gets so difficult to forecast that you might be better off trying to collaborate with your client and rethink your whole supply chain process rather than to fight trying to improve your forecast. No causal forecasting with top-down and bottom-up. If you do this product by product, you might understand some pricing impact, some promotion impact. But if you do this at the segment level, it gets more and more difficult. So this causal forecasting is quite difficult with hierarchy forecasting. So maybe I missed a question, but again, I have another 2 slides. So let's just move. So the question I asked here is, which one's the best? The answer is either, and some of you said it, it's both. That would be definitely the best, and we're going to discuss that in a minute. Otherwise, it's a case-by-case question again. It really depends on how much data you have. If you have no data, you just have past sales, you don't even have the choice, so it's no point to cry about it or to discuss. You have to just do time series forecasting. If you have more data, you can try both and see which one's the best. Again, in one case, it might be one. In another case, it might be the other. Now I think this is the last slide, comparing another kind of method. On the left hand, you get statistical model. So those are models where you have data and you come with a model that you create yourself and you say to the model, okay, you have to, I don't know, flag some sort of seasonality, flag this kind of impact for the pricing, flag this kind of trend, and the model is going to understand the trend and seasonality and project it, right? So the model will do exactly what you ask the model to do. Machine learning is very different. Basically, you just bring data and you hope that the machine itself will understand what is going on in there and will understand if there is a seasonality, if there is a trend, if there is an impact by with the pricing and so on. So it's much more powerful in the sense that it can understand a lot of things, but also it's a black box. I once read on internet, if you understand it, it's not machine learning. I do totally believe that this is the case, right? Machine learning will never provide you an explanation on why a forecast is high or low. That's a pity, but on the other hand, it might be quite accurate. In terms of data, it also requires often much more data than a statistical model. A statistical model, if you just have one product, 3 years of data, you can do a forecast. Machine learning, you might need thousands and thousands of products so that the tool has the time to understand how the data is going. So last question for you, which one is the best? I think based on the time, that will be the last debate. And by the way, someone said, Tuan said, I would test both methods and choose the one with the lowest error. I think this is definitely the best answer to all my questions. I really encourage you to do that. If you hesitate in between 2 techniques, just try them both, see which one worked the best, and just keep the one, right? That's really, I think it's really a supply chain data scientist mindset. If you have any doubt, try both and just pick the best one. While you go on maybe with 1 or 2 more questions, I just would like to advise some books that I really enjoy. So you have the Business Forecasting Deal. It's a general book by Michael Gilliland about forecasting process. It's quite good. On the right hand, you have the very simple book to read. If you're totally new to forecast or demand planning, this is really the book you should start with. Simple subject, properly explained. It's great. Concerning models, if you're into time series forecasting and you want to have the very academic book, this is the one, Forecasting by Hinman. On the right hand side, you have my own book, Supply Chain Forecasting Model. I'm using most of the time machine learning. If you want to start machine learning starting from scratch, this is the book for you. Finally, if you're into data-driven judgmental forecasting, I love the book on the left. It's an amazing book on how people can make good prediction. And the one on the right is one of the, I would say, forecast data scientists in the US. It's quite good as well. That's it for me. I don't know, Fotios, if we have the time for a few more questions. I will share the presentation. Yes. We will share again. We will share the video and the slide. We will do that. Yeah. But just if you had flagged the previous question that you want to discuss before the end, I'm very happy to do so. Someone is asking about consensus forecast. So consensus forecast is just another, I'm sorry for the red mark. I don't know how to take that out. Consensus forecast, wait. It's just another name for what you're gonna get to at the end of the forecast value added process. So right here, this is the final set. So this is the consensus forecast in the sense that everyone agreed to, in the end, we should agree on this forecast, right? The forecast value added framework is gonna help you to make this process as good and as efficient as possible. Aruna, I do not understand your second question. If you mind to rephrase that, take the average over baseline. Ibrahim, I'm not sure neither I understand it. But and it's some I do not use those kind of technique. It's a highly technical question, but I do not use personally those kind of technique. Others do. Again, I would give it a try. If you think you have an idea for a good model, I would definitely give it a try. I personally do not use those kind of. Someone's asking if machine will replace human. Well, it depends on which task. For forecasting, it's already the case, and for some other cases, it might be. Where can I find your blog? We will share the slide with this presentation, and the address of my blog is in the slide, so you will get it. What divide the skew? I do not understand your question, Irfan, sorry.
Right. Well, thank you so much, Nicolas. This was an excellent talk, excellent presentation. Thank you so much for joining us. And thank you so much to all of you who have joined this presentation. As we said, the session has been recorded and we will share it online. And we will also share Nicolas' slides for future references. Thank you so much again, all of you, for joining us, and have a great day.
Perfect. Thank you. Bye.
Thank you. Bye-bye.
Ciao.